Today let's learn about inverse Z transforms. So Z transform of Un is nothing but U bar of Z. So inverse of Z transform is given by Z transform inverse. This is a notation of U bar of Z which is equal to Un. So this is a notation for inverse. Z transform inverse of your answer, that is U bar of Z, will give your function back. So if you apply Z transform for Un, you will get U bar of Z. If you apply inverse Z transform for U bar of Z, you will get Un back. Okay. So now what I will do is, you can guess the formula on your own. Now try to see the function on the left hand side and try to connect it to the correct formula. Okay. Z transform inverse of Z by Z minus 1. Where you have seen Z by Z minus 1? So Z transform of which function is Z by Z minus 1? Let me put it that way. So it is Z transform of 1. So, and similarly guess these three. You just guess this. If you know the formula for Z transform, you can write the inverse formula on your own. Just try to write it in a rough notebook. Let's see whether your answer is right or wrong. Ready? Yes. Z transform of 1. So this is nothing but 1 power n. Remember, from k power n we have substituted k is equal to 1. So Z transform of k power n is Z by Z minus k. So inverse of Z by Z minus k is k power n. So you are not studying any new formula. And Z by Z minus 1 the whole square. This is nothing but Z transform of n. So I have written n here. This is k power n into n. Remember, Z transform of k power n into n. We have studied kz by z minus k the whole square. Similarly, Z transform inverse of z square plus z by z minus 1 the whole cube is nothing but n square. Same way, Z transform inverse of kz square plus k square z by z minus k the whole cube is k power n into n square. Everything is the same, extra k term is coming. And Z transform inverse of z cube plus 4z square plus z by z minus 1 the whole power 4 is nothing but Z transform of n cube. And similarly, kz cube, see this last formula, kz cube plus 4k square z square plus k cube z by z minus k the whole power 4 is k power n cube. And these two formulas, it's a particular case. Remember, cos n theta and sin n theta we derived. And I told you that we'll be using this in inverse formulas. So sin n theta, that theta is pi by 2. This is a particular case. So we will get the answer as z by z square plus 1. And cos n pi by 2 is z square by z square plus 1. So here we will be using these two. So little extra formulas over here. And finally the impulse function, we have seen that in the previous video. So Z transform of delta n, that is unit step function, is nothing but 1. So inverse, Z transform inverse of 1 is delta n. So these are the inverse formulas. So we did learn something new over here. All our old problems and all our old formulas, and we are just trying to express in terms of inverse. And this is the basic for all problems till the end, solving the difference equation. Till that we will be using this technique. So find the inverse Z transform of U bar of Z is equal to Z by Z minus 1 into Z minus 2. This is a question. Okay, this will be a part of solving a difference equation. Okay, so this is something like a warm up. Try to understand the concept. And left hand side we have U bar of Z, and always try to preserve this Z in your problem, because in any Z transform formula Z will be there in the numerator. Correct? So I am just pushing this Z down to the other side, that is U bar of Z by Z is equal to 1 by Z minus 1 Z minus 2. So eventually what I am going to do is I am going to resolve it into partial fractions by a by z minus 1 plus b by z minus 2. I will find a and b. Then whichever z is there on the other side, I will push it to the numerator to the formula format. Now for the time being, I am taking this as a separate problem. 1 by z minus 1 into z minus 2 is equal to a by z minus 1 plus b by z minus 2. And then cross multiplying a into z minus 2 plus b into z minus 1 by z minus 1 into z minus 2. We are taking LCM of it. Yeah, I have rewritten the same thing just to have a continuation. So a into z minus 2 plus b into z minus 1. Okay, divided by z minus 1 into z minus 2 will be there in the denominator if I take LCM. So that LCM denominator and left hand side denominator will get cancelled. That is why we are getting 1 is equal to a into z minus 2 plus b into z minus 1. Hope you know partial fractions very well, but still for your reference I am teaching again. So once you got this equation, that is 1 is equal to a into z minus 2 plus b into z minus 1, we are going to substitute suitable value to get a and b. So if I substitute z as 2, a will become 0, I will get b. So 1 is equal to 2 minus 1. So 1 is equal to b into 2 minus 1. So 2 minus 1 value is 1, b is equal to 1. Same way, if I substitute z is equal to 1, then b will become 0. 1 minus 2, I will get minus 1. Minus a is equal to 1, therefore a is equal to minus 1. So we got a and b. So u bar of z by z, we are going to substitute this in the first step. First step we got u bar of z by z is equal to 1 by z minus 1 into z minus 2 we wrote, correct? So that 1 by z minus 1 and z minus 2, we are splitting it into partial fractions. A by z minus 1 plus b by z minus 2. In the place of a I am substituting minus 1, in the place of b I am substituting 1. And then now I am pushing this z to the numerator on the right hand side. So u bar of z is minus z by z minus 1 plus z by z minus 2. Now as I told you, you have to be very much thorough with the formulas. You should be able to connect to it just like that. Push this negative sign outside. So z transform, now we are going to take inverse on both sides. So far you have just simplified the formula, problem to the formula format. So z transform inverse of u bar of z is equal to minus z transform inverse of first function plus z transform inverse of second function. So this is z by z minus k, correct? This is the formula. So we get this negative sign is there outside. In the place of k I have 1 power n plus z by z minus k power n only. In the place of k I have 2 power n. Please remember this z minus k. Don't get confused with this negative sign. Compare it with the formula z minus k. In the place of k I have 2, so I have written 2 power n. So un is equal to 2 power n minus 1. So we got the inverse z transform for the given function. Now see this problem. U bar of z is equal to z into 2z plus 3 by z plus 2 into z minus 4. Okay. Here this z I want to preserve it for the formula, because denominator if you see z plus 2 z minus 4, simple things. So I want z in the numerator. So this u bar of z by z I am pushing it to the other side and keeping the rest of the things on the right hand side. Now what I have to do, I have to simplify and resolve it into partial fractions. Which term? 2z plus 3 by z plus 2 into z minus 4. So now this is easy. Can you try it on your own? Yeah. If you see this, I am just taking this 2z plus 3 by z plus 2 into z minus 4 is a by first denominator plus b by second denominator. Same LCM, a into z minus 4 plus b into z plus 2. Divided by these two terms will be there, and this term will get cancelled. That is why we are not writing the denominator at all. Directly we are writing. So here in the numerator 2z plus 3, because both the denominators will get cancelled. Now what is a suitable value to substitute? If you substitute z as 4, a will become 0. Okay. B will become 6b is equal to left hand side what will happen? 8 plus 3, 11. So 11 is equal to 6b, therefore b is equal to 11 by 6. Similarly, here if you notice plus 2 is there, so I have to substitute z as minus 2 to make this 0. So if I substitute minus 2, it will become minus 2 minus 4, a into minus 6 I will get. Left hand side minus 4 plus 3, so again negative sign will I will get. So this negative sign and right hand side negative sign will become positive. 1 is equal to 6a, therefore a is equal to 1 by 6. So we got A and B. What we will do? Here we are going to substitute. So u bar of z by z is equal to this term only I am writing here. So directly I will connect it here. Because this term and this term are same. So u bar of z by z is equal to 1 by 6 by z plus 2 plus 11 by 6 by z minus 4. Then denominator z we will bring it to the numerator in the next step. Yes. So same thing we have substituted. U bar of z by z is equal to 1 by 6 into first denominator plus 11 by 6 into second denominator. Please be careful whether A or B, whichever value you are getting, substitute accordingly. Okay. So this z I am pushing it to the numerator. So z by z plus 2, z by z minus 4. These are all just constants. 1 by 6 throw it outside. Now you apply inverse transform on both sides. Z transform inverse of u bar of z, as per definition it's un. 1 by 6 into z by z minus k, right? Z plus 2 how I will write? Z plus 2 I can write it as z minus 2. Okay. So I can write z plus 2 as z minus 2. So now I am going to compare this z minus k. In the place of k what I have? Minus 2. Please be careful. So z plus 2, again I repeat, this is nothing but z minus 2. So z minus k, in the place of k I have minus 2. That is why we have written minus 2 the whole power n. And then if you see the second term, it's simple. Z by z minus k. In the place of k I have 4 power n. So this is the solution for the given u bar of z. So what are the basic properties of partial fractions that you have learned so far? You will be applying that. And one more problem. If you are used to these kind of problems, then directly we can go for solving a difference equation. U bar of z is equal to 2z by z minus 1 into z square plus 1. U bar of z, I am going to preserve this z, so I am pushing it to the other side. Finally, I will bring it to the numerator. So 2 by z minus 1 into z square plus 1. I am just keeping this as it is and I am going to simplify this. Again, resolving it to partial fractions, see here, there is z square plus 1. So how you will split? A by z minus 1 plus bz plus c by z square plus 1. It should be in the formula format, that's our main thing. Okay, because there are few ways in partial fractions, but I want it in the formula format. And if you see this, directly you can guess the answer actually. So here there are 3 terms, right? A by, and then once you substitute b and c value, you can write it as a separate numerator and denominator. So 1 by z minus 1, so it's nothing but 1 power n. Same way here b, if you substitute, you will get z by z square plus 1. Correct? 2 terms will be there. So one term will be definitely in the form of z by z square plus 1. Could you please try to connect to the formula pattern? Which formula? Yeah, now where z by z square plus 1 is there? Sin n pi beta. If the numerator is z square by z square plus 1, we will use cos n pi beta. So you have to be very thorough with the formula, so that by seeing the denominator you should be knowing whether to split the denominator or keep that as it is. So 2 by z minus 1 into z square plus 1 is a by z minus 1 plus bz plus c by z square plus 1. Now we are cross multiplying a into z square plus 1 plus bz plus c into z minus 1. And both the sides denominator will get cancelled, so we didn't mention that. So if you see this, if I substitute z as 1, this term will become 0, I will get a. So a into 1 plus 1 is equal to 2, so 2a is equal to 2, a is equal to 1, this is easy. Same way, if I substitute z as 0, if I substitute z as 0, what you will get? 2 is equal to a into 0 plus 1, so it is 1. Plus, I will write it. Yeah, I have rewritten the same thing. So 2 is equal to a into 0 plus 1 plus this is bz. So in the place of z we are substituting 0. So b will become 0 plus c into 0 minus 1. We know a value is 1, so replacing it y1. So 2 is equal to 1 plus c into minus 1. So minus c is equal to 2 minus 1 will become 1, minus c is equal to 1, therefore c is equal to minus 1. So we got a we got C. Now we have to substitute another suitable value and continue to find the missing value B, or is there any easy way? If you see the coefficient of B here, okay, what is the coefficient of B? Bz into z square, correct? Here coefficient of z square is A, here coefficient of z square is B, here coefficient of z square is nothing, 0, because this is a constant term, 2, right? So we have to compare the coefficient of z square to find the value. So what do we get? So here left hand side coefficient of z square is 0, az square plus bz square, right? So a plus b we have written, therefore b is equal to minus a, so b is equal to minus 1. So this is the answer for B. Now we know what is the value of A, B, C, just we have to substitute in this equation. So 1 by A is 1, right? So 1 by z minus 1 plus minus 1z by z square plus 1 plus C value is what we got, minus 1 by z square plus 1. So we will get 3 terms. So then we can split numerator. Yeah. Now you can see those 3 terms, 1 by z minus 1, minus 1z by z square plus 1 plus minus 1 by z square plus 1. This is bz plus C. We have separated the denominator because there is no minus 1z minus 1 divided by z square plus 1. There is no formula. So I am splitting the numerator. Now this z I am taking it to the other side finally. After writing it, now beautifully it's looking in the formula format. Z by z minus 1 minus, this minus I am pushing it in the front, z square by z square plus 1, this minus I am pushing it to the front, and z power 1, this is not 0, this is z power 1 by z square plus 1. So now applying inverse transform on both sides. Please mention that. Apply inverse transform on both sides. Z transform inverse of u bar of z is un. Z by z minus 1 is 1 power n, and this is cos n pi by 2 formula, and this is sin n pi by 2 formula. Just we are using the formula. So we are resolving it by using partial fractions and bringing it to the formula format. That is the secret. And there are few problems. If you see this, you may get confused. 2z square plus 1 by z plus 1 into z minus 2. So in all the problems so far we had some z in the numerator, we will push it down. So here 2 terms are having z, means I can take one z common. So if I cannot do it, multiply numerator and denominator by z. Again preserve this z to the other side. So keep this denominator z as it is. So 2z square plus 1 by z by 2z square plus 1 by z into z plus 2 into z minus 1. So if you resolve it, a by z, b by z plus 2, c by z minus 1. Okay, so here partial fraction is nothing, but what I want to insist is, if z we cannot take it common, automatically if you take it common also, denominator 1 by z will be there. In case if this problem is 2z square plus z, I will take z common and push that z to the other side to save it for the formula in the numerator. So if not there, just multiply numerator and denominator by z, keep this z to the other side and resolve this into partial fractions. That's it. We will see more problems based on inverse z transform in the next class. Thank you.